will join us shortly. Right. Uh, okay. I believe my screen is visible to every one of us, right? Now, before we go into the AWS environment, okay, yeah, thank you. Thank you. Before we go to the AWS environment, I really want to just, give us a bit of an explanation regarding networking. All right. Now, like I said, networking is the foundation of, all right, cloud computing, because somebody who is, all right, in the US or in the UK or even in Nigeria, okay, can be in the comfort of his or her room, then it's able to access, systems from anywhere. Of course, as we all know, for example, services like Facebook, Twitter, Instagram, all those major services that we use every day, right? WhatsApp and all of that, the servers are not, most of the servers, in fact, all of them are not even in Africa, right? Quite a number of those servers are actually in the US, okay? Majority of them are there. And somehow, somebody even in a remote part of Nigeria, as far as you have data on your mobile phone, you can access those services. All right. So that's just basically, how important network is. It doesn't matter how sophisticated your software, all right, or the application you have developed, how sophisticated application looks or is, right? If there's no internet, if there's no network, there's no way, okay, that software can be usable. Okay, so network, it's really something that is very important. Now, this diagram that we have on the screen is just basically talks about the foundation of network, right? Data communication. How does data communication actually work? Okay, so how does it happen that I open my phone and I go to yahoo.com and somehow, I get that page, right, back on my phone and I can log in, put in my credentials, log in and do whatever it is that I want to do on that particular site, right? Or how is it that, anytime I put on my data, somehow all the messages that have been sent to me, right, just begin to download. I begin to, my mail just, get updated automatically. I get WhatsApp notification, Facebook notification, all right, any kind of, notification that has to do with the internet or any app, all right, that has, some kind of inbuilt messaging system, okay, I get those messages automatically. So let's look at what you call the OSI model, which is the open system interconnection. I want to explain this to us before we go into the console and then start, all right, creating VPCs and all. So let's just understand the foundation of the states, right? Now, the open system interconnection, it's a 7-layer model. So how did it come about, this model? Right, some decades ago, the U.S. Department of Defense, they call them the DoD. Okay, because when it comes to research, I think the United States is at the forefront of most of those things. So the old network and the OSI model thing, all right, started from them as well. So the Department of Defense, all right, came up with an idea. Now they had some institutions, right, all around the United States. And then they were thinking that, this institution, we need to find a way to connect all those institutions, all right, together, right? So that, we don't have to move from one place to another in order to share information and data and all of that. So they talked about it. Okay, so what could we do? What is that thing that we can do to bring all this institution together such that, right, you can be in your institution and then you can access something hosted in another institution and then, vice versa. Okay. And then they came up with this concept of what you now call the OSI model. And then they came up with this 7 layers, right, of the OSI model. Okay. They came up with the 7 layers of the OSI model. Okay, I'm trying to zoom it in so that we can see it clearly. All right. Okay, so they came up with this. Just a minute. All right. Now, okay, I think that's a bit better. All right. So they came up with those 7 layers of the OSI modem. Now, if you look at it, you have from layer 1 to layer 7. And quickly, I'm going to be explaining to us, what this layer is all about. Now, like I said, it's something that came about as a result of, the research, all right, that the Department of Defense, the United States Department of Defense was trying to do. And then they came up with this layer, all right, the 7 layers. Now, initially, when, computing, organizations started using computers, right, they had a problem. Now, what was the problem? Different organizations were manufacturing computers, right? So the challenge they had then was that computers that are manufactured by organization A are not able to communicate with computers, all right, that are being manufactured by organization B. So which means in an organization, if you want to buy a computer system, you have to buy from the same manufacturer. All right, so you cannot buy from HP and buy from Lenovo and buy from Dell. All right, it has to be from the same manufacturer. So that problem was also there, in addition to the fact that the Department of Defense were also trying to connect different organizations together. Okay, so that also contributed partly to the OSI model. Now, let's quickly look at the 7 layers. What does it mean? What does it do? Now, the physical layer, it says it transmits raw bit streams over physical medium. Now, one thing you must understand is this, right, in networking. Now, the reason I'm providing us with all these theoretical details is because so that by the time we get into the system and then we start provisioning certain things, you will understand, all right, some of these things that we're talking about, all right, because sometimes if you really want to be good practically, you must also understand the theory behind what you're trying to do. It is really very important, right? So it's not just about practicals. It's not just about, all right, trying to do all those things. And that's why somebody who is a welder, okay, it would not earn as much as somebody who did, maybe metallurgical engineering in the university, because the person that did metallurgical engineering has the theoretical knowledge of what the welder is trying to do, okay, and then is able to guide that welder properly to say, this is how you should do your job, right? But the welder only knows the practical. He only knows that, you get an electrode, you put everything together, and then you can put this and add it together, then you have your pole, you have your iron, and all of those kind of things. And that's why, so when you have a welder in an organization, and then you have somebody who did metallurgical engineering in an organization, of course, they cannot earn the same. The person who had his degree will, of course, obviously earn more than somebody who, did, welding. Okay, so for everything that you try to do practically, it is important to also understand the theory, all right, behind what you are trying to do. Okay, and that is why if you really want to know somebody who is a good programmer, right, somebody who can really code very well, you should go and find out there must be people who really understand mathematics. All right, it's very important. So I just thought to say that. Okay, so let's understand the theory behind this whole network stuff, so that we can, understand what networking is about. Now, this is the layer that actually guides our network communication over the internet, right? You send something to me, I send something to you, I call somebody up on WhatsApp, and the other person picks up, at the other end, right? So it's just, this layer is what is responsible. So the first layer talks about the physical layer, and it says transmit raw bit streams, all right, over the physical medium. Now, before you can begin to get updates on your mobile phone, now the first thing that you do is that there are 2 things that you can do. Now, the first thing is that you look around in your environment. If there's a Wi-Fi network you can connect to, you connect to it, and then with that, you are able to operate your phone. You're able to connect to different services online. Now, if there is no Wi-Fi network that is available in that environment, the other thing that you can do is to subscribe, all right, buy data subscription from the, telecom provider that you're using. And so with that, you are also able to access the internet. So the physical layer actually talks about that, all right, transmit raw bit streams over the physical medium. The physical medium, in this case, now can be a wireless device, so which means you are connected wirelessly. The physical medium in this case can be the SIM that is inside your phone, and then you do a data subscription, and that gives you access, all right, to internet. Now, the physical medium also in an office environment can mean that your desktop, all right, is connected to a LAN, okay, which is, of course, will be in the server room of the organization. So that is the physical medium, all right? So the first point, all right, of connection to the internet is actually through a physical medium. So you have to be connected. That's the first thing. Now, the second layer talks about how data is being formatted, all right, when that data is being transmitted. And that second layer also talks about different protocols at that layer, right? Part of the protocol that works at that layer are things like, your MAC address protocol. MAC address stands for Media Access Control. Every electronic device, right? Every electronic device has a MAC address, right? Every, anything that has to, any computer device at all, mobile phones, anything that, at least as far as that thing can connect to the internet, has a MAC address. Even all these sophisticated, deep freezer that you have that you can connect to the internet, you can browse, they have the screen on them and all that, they have a MAC address. And MAC addresses are unique across devices. There are no two devices in the world that has the same MAC address. Now, the layer 3 talks about, all right, the physical parts that the data will take. Now, that layer 3 is where you have things like IP addressing, which we're going to be seeing shortly on the AWS console. That is where you define your IP addressing, the IP address that your system will use. Now, if you have noticed, you will discover that even your mobile phone, the moment you put on your data on your mobile phone, now your telecommunication provider gives you a kind of IP address on your mobile phone. And that is why if you share your mobile hotspot with your laptop, you will discover that your laptop also has an IP address. So you begin to wonder, so where did the IP address come from? It came from your phone, because your phone, as small as it may look, also can be a form of it can be, all right, can serve also as a DHCP. All right, so DHCP is basically a dynamic host control protocol, so which means a service that helps you to generate IP address automatically and assign it to, all right, different devices. So the network layer is at the layer 3, which is where, all right, that decision is made. IP addressing, what path will it take, and that's where you have the concept of things like a switch, a router, all those kind of things. All right. Now, for most of us, your mobile phone, okay, it also operates at that network layer. All right, because your mobile phone can serve also as a gateway. In what sense? All right, in the sense that if you turn on your mobile hotspot and you share that with your laptop, right? Now, all the things that you're doing on that laptop, everything is going via the network on your mobile phone. Okay, so in that sense, your mobile phone is standing as the gateway, because the moment you switch off the hotspots, then your laptop is no longer able to browse. You are no longer able to do anything on your laptop. But as long as the mobile hotspot on your mobile phone is still on, right, you are still able to browse. So all the things that you do on your system, the Facebook, the email that you're sending, everything is being routed, all right, through your mobile phone. So your mobile phone can set to be, all right, at the network layer, which is, of course, the physical part that the data will take. So all the things that you're doing on your system is actually going via your mobile phone. And then at the transport layer, we have transmit data using transmission protocols. Now, what is a protocol? What does a protocol mean? A protocol basically just means a set of rules, all right, that guides, okay, communication over the internet in this case. All right, so protocol is just a set of rules. Now, in that protocol too, we have two kinds or two types of protocol that guides our communication over the internet. All right, now the first one is the TCP, Transmission Control Protocol. The other one is what is the UDP, which is User Datagram Protocol. Now, the TCP is said to be reliable. All right, so which means you can consider the TCP to be like a DHL service, all right, or a FedEx kind of service, which of course, when you send, parcel through DHL and all that, they give you a code, you can track, all right, your item as it's going from one place to the other. Or a very good example in Nigeria is when you order something on Jumia, right? Or on Konga, there's a way for you to track it. Even on your mobile phone, you can see, okay, the item has left the warehouse, it has gone to this point. So there's that reliability there. Okay, so and when there's reliability, you have peace of mind. You are sure that these guys are not fluke. Okay, you are sure that whatever it is that you're sending is going to get to that destination, all right, and the person that is in that message is intended, all right, to get to will also get that message. So for transmission, we have two protocols. There's the TCP transmission control protocol, which is reliable. Now, an example of a TCP service is your email. Now, I'm sure some of us must have had that experience in a case where you send an email to an address, maybe to a Gmail address or to a Yahoo address, and after some time you get, all right, something that is called a mail, delivery subsystem or something. So which means that mail was not delivered. All right, now that's some kind of reliability there, because if you don't get that kind of a message, there's no way you will know that the person didn't receive that email, or maybe that email was not even correct in the first instance. All right, so that's reliability right there. All right, so example of DHL, example of Jumia, example of your email. So it talks about reliability, and that is what TCP is known for. So basically, the TCP protocol ensures that every message you transmit using that protocol, all right, it gets to the destination regardless. All right, so the TCP has some kind of feedback mechanism that will ensure that you have sent the message, you get some kind of feedback in return to let you know that the message you have sent has been delivered. Now, the UDP on the other hand can be said to be unreliable. Now, a very good example of UDP is this. I'm sure most of us will have encountered that. Now, you pick up your mobile phone, you call somebody somewhere, and then, 2 minutes into the call, the voice starts cracking, right? And then you say, oh, hello, 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 oh, I didn't hear what this person said. Hello, can you hear me? That is UDP right there. Now, in the case of TCP, what TCP does is this. For every message that you send, all right, using TCP, now, if that message does not go through, it gives you feedback that, oh, your message didn't go through. All right. And then if there's a kind of, maybe the network is slow and some kind of stuff like that, your TCP protocol tends to retransmit and ensures that every message gets to the owner without any kind of delay. Now, another example of TCP is this. Now, for some of us that are using, smartphones, right? Or maybe some of us who have used smartphones before, now you will discover that when you send a message to somebody, now sometimes the person will receive that message in half. So which means part of the message will not, enter. And then when the person receives the message, the person will see some kind of dots. So which means this message, this is not the complete message. So there's still some more coming, right? And then after some time, the person can look at their phone again and then they can see a new message. And then somehow they open it again and they see that the message that they received earlier that was not complete has been completed, right? That is an example of TCP, making sure, right, that every message you send, the person gets it 100%, that nothing is missing, nothing is broken. That is an example of TCP. Now, UDP on the other hand, now you will discover that all those times that you will make a call and then you're saying, oh, hello, I can't hear you, please, can you speak loud? I can't. The person say, for me, I can hear you. And you say, well, I can't hear what you're saying, all those kind of things. Now, you discover that some of those information that the person was trying to communicate that you couldn't get, you discover that those information somehow were just lost. They were not retransmitted. You couldn't even get them back again. The only way you could get it back is to cut the call and dial that person again. Okay? And then you ask the person, oh, what were you trying to say earlier? Now, what that person was trying to say earlier has just simply been lost in transit. All right? So for UDP, that is just the way it works. And so that's why UDP is used in things like your voice over IP, right? Voice communication, video communications, or other streamings that we do online and stuff like that uses the UDP protocol, because you can't guarantee, all right, the delivery of such information. So those ones, they tend towards the UDP, the user datagram protocol. So TCP is reliable, all right? UDP on the other hand is unreliable, and I've given us examples. Now, the section layer here says maintain connection and response for controlling ports and sections. Now, what is ports? Now, for every home, all right, there's an address. Okay, every home has an address, and every address has what you can call what is it called now? A zip code, right? Every area has a zip code. Okay. Now, that address is what you can use to identify a place that you're going. For example, if you want to order an Uber ride, you'll put in the address of where you are going to, all right, on that Uber ride, and then, okay, it shows you, oh, okay, if you're moving from this your location to this particular address, all right, this is going to be the cost. Now that address, all right, and the zip code that you see can be referred to as, the port numbers. Now, every protocol, now we said protocol is a set of rules, right? Now, every protocol that works on the internet has a port number associated. Okay? Has what? A port number associated. Just like every home has a street number. Okay? Just like every home. There's no home, at least for, in advanced countries, they have numbers, flat 10, flat 2, okay, block 1, block 2, and all of that. And then in Nigeria, you also have maybe house 10, house 15, house 5, all those kind of stuff, right? So all those numbers that have been assigned to those houses can be referred to as port numbers. Now, for every protocol on the internet, there is a port number associated. Okay, so if I browse on the internet, I use a protocol that can be called as HTTP. There's the email protocol. If I send an email to somebody, there's a protocol responsible for that, and there's a port number for that. All right. If I do a voice call to someone, there's a protocol and there's a port number responsible for that as well. And let's just look at now the presentation layer that is responsible for presenting the message in a readable format. And then the layer 7 is the interaction layer, all right, where you can view things the way they are. So quickly, let's just look at this. All right, now look at the protocol. So for each of the layers, we have the protocols. So the physical layer, you have the internet and the Wi-Fi. The data link layer, you have, all right, the CDP, you have the STP. The network layer, you have what I said earlier. You have your IPv4, which is your IP addressing. Transport layer, you have the TCP, UDP. Session layer, you have this. Presentation layer, you have all these. And then application layer, you have the DNS, DCP, blah, blah, blah. All right, these are the protocols for each of the layers. Okay, now, so these are popular protocols and port numbers. All right, now let's talk about this guy. All right, this particular guy right here, the DNS. Now, what is the function of a DNS? Now, from the name, the domain name system. Now, that domain name system is a protocol, and it has a port number 53. But the question is, what does a DNS do? Now, for every one of us, all right, the fact that you are even on this call today, all right, shows that you are able to maybe use your phone to connect, or maybe use your pad or your iPad or your laptop to connect, all right? Now, when you want to go to Zoom, you open your browser, and then you type in zoom.us, right? That's the name you typed. But behind that name, there is what you call an IP address. All right, there's an IP address behind that name. Okay, now let me show us something here in order to explain this DNS that we are talking about. All right, let me show us something. Now you can see my shell screen, right? So if I do ping zoom.us, now something happened. It gave me the IP address behind Zoom. Okay, so which means zoom.us has an IP address of 170.114.52.2. That's the IP address of Zoom, all right, .us. So which means the Zoom that we are using right now, one of the server that Zoom is hosted on has this particular public IP address. Now, how did DNS come about? Now, you can imagine if you want to go to Zoom and you want to connect to this meeting, you can imagine if you have to cram this particular IP address. Now, not everybody can understand these things. All right, not everybody can put this number in their head. And it's not even reasoning, because there are several websites that you want to visit. For example, if you want to go to Zoom and then they tell you this is the IP address of Zoom, you want to go to Jumia, they give you another IP address. You want to go to maybe Amazon to order something, they give you another IP address. How many IP addresses can you put in your head, right? But it is easy to just say, oh, let me go to zoom.us. Oh, let me go to Amazon. Oh, okay, let me just start Jumia, and then let me go to Jumia. You know, it's easy that way. But behind the scene, what your DNS does for you, because your computer system does not understand alphabet. He only understands zeros and ones. All right? He understands what? Zeros and ones. That's what the computer understands. So they came up with the idea of DNS to say, you know what? People cannot survive putting, trying to memorize different IP address for different servers and all of that. So we need to find a way to map that IP address to a name, so that anytime they type in that name, behind the scene, right, the system, all right, does what you call translation. It translates that name back to an IP address, to numbers that your computer system can understand. And that's why if I do ping, for example, and I do Amazon, all right, .com, it gives me an IP address for Amazon. Okay, so that's the IP address for Amazon. Okay, so the DNS is just a concept to say, you know what, let's provide a system that for every IP address that you want to make public, for every application that you want to deploy for public consumption, right, it's going to be hosted on a system. That system is going to have an IP address, but let us have a system also in place whereby we can map a name to that IP address. So what the people will have is just the name and not the IP address, so that people that way can understand it. So for example, even if I don't know the address, all right, even if I don't know the address of Zoom, for example, or I don't know their website, right, all I can do, I could just go here to my browser and just type in, all right, and just say, okay, search for Zoom, and then it searches for Zoom, and then I just click on this, and then it takes me, all right, to the Zoom space. Okay, so that is, how the DNS stuff came about, and then from then on, we now have what you call names and all those kind of stuff. All right. And then you have other protocols like your HTTP protocol for web address, your post office protocol, and things like that. All right. So let's go over to the console and let us, all right, try to see what the VPC is all about. Now, before you deploy a service on AWS, now there are quite a number of services that makes use of the VPC. Like I said, all the servers that you're going to deploy, all right, in the AWS environment, your EC2 instance and all those other stuff, all right, everything needs, all right, a network to operate. They need an IP address to function. Just like we saw now that, all right, if you want to go to Zoom, Zoom has an IP address and all that. So if I have, all right, a website on my system, or maybe I want to host a website on my system, of course, I need a network for that to function in order for people to be able, all right, to access that particular system. Okay, so your VPC is something that is really very important that you need to understand how to provision. In fact, for quite a number of the, the cloud providers, they have a certification that is dedicated even to networking on AWS. All right, so AWS has a certification dedicated to just networking on AWS. I think Azure also has something similar. All right, because it's really very important. Okay, I don't know why my network is slow, but let me see. Just a minute. Now, if you want to go to the VPC, you can simply type in VPC here in the search bar, and then it will take you to that particular space where you can have access to a VPC. Okay, just a minute. Coming. I want to try and all right, so we are at the VPC section. So let's see how, all right, this section works. Now, there are a lot of services, right, which may not be able to cover completely, But there's VPC, there's subnet, there's route table, there's internet gateway, and there's NAT gateway. All right. So let's look at these things, all right, quickly, and let's see what we do. Now, if you click on VPC, that is where you can provision, all right, your IP address. That's where you can provision the size that you want and all those, all right, good stuff. Okay. I'm trying to see what's going on. All right, so that's where you can provision all the necessary stuff. So now, how do you provision, all right, an IP address on AWS that your EC2 instance can make use of? Now, let's go back a bit and let's provide some explanation. Now, there are a few things that are important here, which is your VPC, subnet, route table, and internet gateway. Very important, at least at this level. All right, now VPC is where you provision the IP address that you will need. All right, they call it the CIDR block. All right, you provision the CIDR block that you need. So basically what the CIDR block is just about is the number of IP addresses that you want. And that is going to be determined by the number of resources that you want to provision that require IP addresses. Okay, so which means if you are provisioning resources that require, let's say 20 IP addresses, or maybe you are provisioning 20 resources and all of them require IP addresses, then you must be able to have a VPC that can accommodate and give out, all right, those 20 IP addresses. That is what it means. Okay, so if I go to VPC, I can create that. Now, subnet is when you now break it down, all right, the VPC that you've created into smaller networks. Now, remember, we talked about, all right, regions and availability zone. If you remember, we talked about regions and availability zone. And we said a region is just a geographical area. And then I remember correctly that we were talking about maybe the Southwest region, the South-South region of Nigeria, that those are regions. That within those regions, for example, in the Southwest region of Nigeria, you have different states. Those states can be regarded as, all right, availability zones. All right. Now, when you provision a VPC on AWS, now that VPC that you have provisioned is just more like a region. All right. It's just like a region. But when you are deploying your application, all right, you have to specifically choose an availability zone that you want that your resources to be situated. So your subnets can also be regarded as an availability zone. In fact, on the AWS environment, a subnet is equal to a single availability zone. All right. So the VPC is like the region, and then you break that down into different subnets, which can also be regarded as what? Your availability zone. Okay. So for example, if I go here and I click on create a VPC, all right, and then I give my VPC a name. So let's just say, free class VPC. All right. Now, I am expected to provide an IPv4 CIDR. Now, what is a CIDR? A CIDR stands for classless inter-domain routing. Now, how do I get this? Now, in a work environment, for the most part, you are not going to be the one to formulate or to come up with a CIDR. It's actually going to be maybe the solutions architect, right? They will come up with the address blocks that they want to use. Your own is to take those address blocks as a cloud engineer and all that, and then provision, all right, those address blocks. Okay, so that's really your duty. Now, so how do we get this IPv4 CIDR? Now, pretty simple. For example, if I open up my search box here and I type in IP address calculator, so if I click here, oh, let me back out. So if I click on this other one, and I scroll down, Now, I have my /24, which is something similar to what we have here. Okay. Now that slash notation, right? That slash you have, this /24 that you have here that we can also see here, is actually what determines the number of IP addresses that you are going to have. All right. So if I come here and I say, okay, 192.168.0.1/24, and then I click on calculate, now it's going to give me some of this information right here. And it's going to tell me that I will have between, all right, 1 to 224. So the number of IP address I can have is what I have here. So which means with this particular address block and with this /24, I can have 254 systems within my environment. That's what it means. All right. I can have 254 systems within my environment. That's what it means. Okay. So which means I can connect 254 resources within my environment. So that's what the /24 here also means. Okay. Now, now you can play around with this. Now this slash ranges from, all right, from 8 to 30. Okay. So which means you can have /8, you can have /9, you can have /10, 11, 12, 13, 14, 15, 16. All right, up to I think /30, right? That's a reasonable size. So if I change this and I say 20, and let's calculate, and let's see what we are likely to get. Now it tells me that I will have about 4,094 hosts. All right, if I use a /20 notation. So that is giving me more hosts, which means the lower than CIDR, all right, the higher the number of resources that you're able to provision. That's what it means. The lower the CIDR, the higher the number of resources that you can provision within your cloud environment. Okay. So for example, if I reduce this to 8 and I calculate, all right, it tells me that I can have as much as 16 million hosts or 16 million resources provision. That's quite enormous. All right. And of course, there's nothing we want to do with that. Okay. And then if you increase it and then you see /30, it simply tells you can have more than 2 hosts, all right, provision. So the lower the number, all right, the lower the slash number, the higher or the more resources that you can provision. In our own case, let's stick with the /24. And so let's do 192. 192.168 10.0/24. All right. And then here I can come here. I can do create VPC. All right. So my VPC has been created. All right. Everything has been created. So if I go to my VPC, all right. So if I go here, I can see that my VPC is here. It's been created. All right. Okay. So it's been created here. This is the IP address that we created. Now, there's another thing in AWS that we must also know. Now, if you look at what we have here, when we put in this 24, all right, and calculate it, it simply tells us that we're going to have 254 IP addresses. But on AWS, that is not always the case. Because what AWS does is that they have some addresses that they reserve for some kind of their own internal use. So instead of 254, what you're likely to get is around maybe 250 or 251. So let's see how that happens. Now I have created my VPC, but in order for me to be able to connect my EC2 instance to this, I need to create what you call the subnet. The subnet, and then I will click on create subnet. So it's asking me here to choose the VPC that I want to create the subnet under. So I'll choose the Tweak class. All right. So I'll give my subnet a name. So let's just say Tweak class subnet. And then now I have to choose an availability zone. Now I told us, I said a subnet is equal an availability zone on AWS, and that is very true. All right, so each of the subnet you provision will be sitting in a particular availability zone. So I'll click here. All right, give it an IP address block. So the same thing, one thing about this is that the same CIDR block that you provisioned for your VPC, you can also use it for your subnet, right? You can also use it as possible. Okay, so that's done. And then I'll click on create subnet. Now subnet has been created. Now, if I want to filter and then I want to see only this particular subnet, it's simple. All I need to do is to come here and then I will select that particular VPC. So the VPC is right here, free class VPC. I'll choose it and that will filter for me. So every information that I will see is also going to be related to the VPC. So if I go to subnets, for example, that's the only subnet that I see. Now, interestingly, if you go here, like I told us, look at the available IP addresses. You have 251. But when we did the calculation, it told us 254. So which means AWS has taken 3 of this address and then they have reserved it for their own purposes. So which means in the AWS environment, when you're using a /24 CIDR, you only have access to 251 IP addresses, which means you can't create more than 251 resources. That's what it means. All right. So VPC has been created. Subnet has been created. Now, in order for us to make use of these resources, there are still a few things that we need to do and pay attention to. All right. Now, I said there's the route table and there's the internet gateway. Okay. Now, if I go back to my VPC, of course, we're still filtering through this, so I'm going to see only that VPC. There are a few things that I need to enable, all right, in order for this VPC to work, and in order for the, all right, resources that I would deploy in that VPC to be able to access the internet. There are a few things I need to enable. Now, if you go to actions, now, if you look at this place, it tells you that your DNS hostname is disabled, so we need to enable that. But our DNS resolution is enabled, so that's okay. So which means our servers that are connected to this VPC are able to do, all right, they are able to restore the DNS to, all right, to IP addresses. Okay, that's what it means. Now, what we did earlier using the PowerShell, pinging zoom.us, and then it gave us the IP address and all that, that is just the DNS resolution. But we need to also enable the DNS hostname so that the resources that we provision on this particular VPC, apart from the public IP address that they're going to have, they're also going to have an hostname that will also be reachable via the internet. Okay, so I'll click on Edit VPC Settings, scroll down, and then I'll check this guy to enable it. Now, one thing you must note on AWS is once you create a VPC and then you have given a CIDR block. Now, even if you now remember later that, oh, this is not a correct CIDR block, I need to change it, I need to make corrections, there's simply no way to edit this information. That's how it has been designed. So the only option you have is to delete it and then recreate it all over again. All right, so that is that. So our subnet is also right here. All right, and then we need to also enable a few things on our subnet. So let's go back to subnet. And we're still filtering through the class subnet, so we can click on the subnet ID. That will open up this broader page for us. There are a few things here that we also need to enable. All right, now you may not see all the information on this particular page. And for your subnet also, once you create your subnet, there's no way to edit, all right, the IP settings. So the only way is to delete and then we create it all over again. So I'll go to actions and then edit subnet settings. Now I need to enable this option, all right, so that every resources that I create on this particular subnet will automatically get a public IP address. Now you can think about that in this sense that anytime you turn on the data on your mobile phone, you automatically get an IP address that gives you access or connectivity, all right, to the outside world. So with your data turned on, you are able to browse the internet and do whatever it is that you want to do with your mobile phone. So the same thing also happens with this subnet. We need to enable the auto assign public IP address so that all the resources that we deploy in this particular space will be able to communicate with the internet. All right. So once that is done, we click on Save Changes. Now we have done two things, but there are still two more things we also need to do, and that is route tables and internet gateway. Now, first of all, let's provision an internet gateway. Now, I explained to us earlier that your mobile phone is also a form of gateway, because if you turn on your data and then you share your hotspot with your laptop, everything that you're doing on that your laptop is going via, the data that you have on your mobile phone. So in that instance, we can say that your mobile phone is acting as a gateway, for your laptop. Because without the mobile phone hotspot that is connected to your laptop, there's no way that your laptop is able to access the internet, right? So in the AWS environment as well, you need to also provision a gateway. So in this case, it's called an internet gateway. And so the way it works is that internet gateway is going to be connected to your VPC, right? It's going to be connected to your VPC. And now don't forget that your subnet is also connected to that VPC. Okay, so which means any resources that you deploy on that subnet and that VPC, automatically they have access somehow, to that internet gateway. So let's see how that works. So I'll click on internet gateway. And now in the AWS environment, you must also understand that you cannot provision more than, I think, 3 internet gateways or so. And a single internet gateway can only be attached, to a single VPC. So which means you cannot attach a VPC to multiple internet gateways, and you cannot also attach an internet gateway to multiple VPCs. So it's one-to-one connection. So one internet gateway to one VPC. That's how it works. So create internet gateway, and then give it a name. So again, let's call it free class. So IGW. So IGW there stands for Internet Gateway. So we create. And right here is telling us that the status is detached. So we need to attach it to a VPC. So if you look at it here, it doesn't have a VPC ID yet. So from here, you can click on attach, and then from actions as well, you can also click on attach. So let's just go from here, and then let's choose our VPC that we created just now. So free class VPC, so we attach it. And you can see that the status has changed to attached, and then you have the VPC ID right here. So that is that. Now, you have connected an internet gateway. Does it now mean that if you start deploying EC2 instances into that your subnet, does it mean that they can browse the internet and then they can have access to internet? No. There's still one thing you need to also do, and that is where your route table comes in. Now, out of all of these things, as important as your internet gateway is, your subnet or your resources will not be able to access the internet if your route table is not configured properly. Now, route table, from the word route table, is where everything is connected together. So your route table is where your VPC, your subnet, and your internet gateway, that is where they are interconnected. Okay. Now, remember, we created our VPC independently. We created our subnet. That one is connected to the VPC. We created our internet gateway too, connected to the VPC. But the route table is what brings all of them together. That's what the route table does for you. Now, let's go to the route table. So route table, Okay. Now, think about your route table as a pot, where if you are cooking, maybe a delicious, let's say you are cooking jollof rice, for example, now for some people, they parboil the rice and then they make sure that they sieve, the water, the starchy water and all that, they throw that away, and then they put the rice back inside of the pot and all of that. But it is in the pot, that's where all the action will take place. Because that rice in itself cannot produce the jollof rice that you want. Now, the recipe for the jollof rice also is not also sufficient in itself to give you that whole package that you want. So you need like a platform where you can put your rice, put your recipe and everything. And then from that same place, you can then serve, your guests, as it were. Okay. So your route table is like that pot where you put in all the other connections, and then it comes out as a O. Okay? So think about your route table like that. So the route table is where your VPC connect with your subnet and then connect with your internet gateway. And with that, your resources are able to access the internet. Now, this is a route table that was created for us by default, because anytime you create a VPC on AWS, it also creates a route table for you by default, or that comes with it by default. And so this is the default route table. So let's edit this and let's give it a proper name so that we can understand and be able to relate with it. So let's call this free class, all right, RT. So RT, that stands for route table. So I'll save. Now, the thing that I need, now this is where the port ideology comes in. Now, if you look at all the tabs that you have here, all right, you have routes, subnet associations. Now, these two things are what we're going to be looking at. Routes and subnet associations, right? Now, if you look at routes, it simply tells us that all the resources, right, that we have connected to that VPC, they are only able to communicate locally. Okay? They are only able to what? They are only able to communicate locally. So which means that if I have like two EC2 instances or two servers deployed in the EC2 section, now those two servers, if they are connected to this VPC, they can communicate within themselves. But now, if they require a communication that is outside of this block of IP address, that is where the internet gateway comes in. Because the internet gateway is what can help them, all right, to navigate or to access, all right, services that are not within, all right, their own local environment. Now, that's why you can see that the target here is local. So which means as far as the service is available locally, then there's no problem. But if you are trying to reach for something that is outside, all right, of your own environment, you need, all right, an internet gateway. Okay? And that's why when you want to send an email, okay, to somebody, you need that person's email address. All right? You need that person's email address because the mail that you want to send, you're not sending it to your own self. You're not sending it to maybe, within your own self, right? You're trying to send it outside. So you need to provide the email address of that person. All right. And then if you put in the email address of that person and then you send out the mail, your Gmail automatically knows how to make sure that that mail is delivered to that recipient. All right. So here we also see the same thing at play. So we have the destination and we have the target as local. So which means anything that you're trying to do within this block of IP address and the target, all right, of what you're trying to do is local. So which means within, then there's no problem. But if you're trying to reach for something outside, then you need something extra. So if you want to do that something extra, you can just come here to say edit route. So you click on this, you add the route. Right here, you put 00. Now in networking, 00 basically means anything and anywhere. So which means if what my server is looking for, if it cannot be found within its local environment, then send it outside. All right. So that 0.0.0/0 just basically means anywhere, right? Anybody, anywhere can access, all right, these resources. And so if I'm trying to look for something that is just, anywhere, all right, that is not within this place, then I need a target, right? I need a target to handle that job for me, a target that knows well how to handle such a traffic. So if I click here, all I need to do is to do what? Click on my internet gateway. And then I'll choose the internet gateway that I've created to say, you know what? Anytime you're trying to reach for something that is not within your own, all right, environment, then send that to your internet gateway. The internet gateway knows how to handle that situation. So I save, and right here, I have my destination as anywhere, 00. The target is internet gateway. So anytime my users are trying to access something that is not within their local environment, then the target that they send us a request to is the internet gateway. All right. So you can see now that indeed your route table is like a port where you mix all the necessary things together. Now, subnet association. It tells me that subnet without explicit association is this particular subnet. Now, I need to associate this subnet to this route table, right? So that every communication that goes through that particular subnet, okay, everything is going to be flowing via this route table. So I need to associate it with this particular route table. So I click on this option here and I go to edit subnet association. And then I choose that particular subnet and then I save associations. So that way, any resource that I deploy on that particular subnet, automatically they are connected to that route table. And by connecting to the route table, if they require access to anything that has to do with the internet gateway has also been connected to that particular route table. So that way, they don't have a problem. All right, so everything is connected. So if you look at it here, you have your subnet associated with the route table and everything seems all right. Now, the last thing we need to do is to enable some ports. Because right now, what I want us to do is that, all right, we're still going to talk about EC2 maybe on next week, Monday. We're going to talk about EC2, all right? So, but of course, for the meantime, I'm going to show us, how to see all these things that we're doing, how to see it work practically, so that it doesn't just look like, okay, so we've done it, so how do we test it? So we're going to test what we're doing, all right? So right here, now, one more thing. Remember, we talked about protocols and we talked about port numbers and all of that. So let's say, for example, I want to deploy a web server, all right, on an EC2 instance, okay, and then I deploy it to this particular subnet. Now, that subnet already has internet access. But in order for people to be able to access my website from outside, all right, I need to enable the HTTP protocol and that particular port number, and also specify that people can access it from anywhere, all right, that they are. Okay, so how do I go about that? Now, there's an option that is called security group. So let's go back again and let's filter via VPC. So let's go to under security, you find security group. Okay, now there are two things that get created when you create your VPC. So the route table is going to be created for you by default, and you also have a security group created for you by default. Now, what is a security group? A security group is just like a service that helps you to protect against unwanted traffic. So think about your security group like a security officer, all right? So for your security officer, you have told your security officer, anybody that wears blue should not enter into this compound. So anytime your security officer sees somebody that wears blue, he says, no, you are denied entry based on the instruction that has been given to me. Okay, and then you can tell your officer to say again, now anybody that wears, white, allow them in. So that's an instruction that you're giving to your security officer. So which means anytime your security officer sees somebody that's approaching your gate and the person is all right on white, your security officer automatically says, well, all right, you are permitted to come in based on the instruction that I have been given. All right, so your security group also works in that light to say, this is the protocol that I want to permit. So you specify that protocol with your security group, you give that instruction to your security group, all right, and then your security group takes that instruction. And so anytime you attach that security group to a particular instance, all right, your security group watches based on that instruction. So anything that you have not defined, all right, any instruction that you have not given it, automatically it denies those requests. But the ones that you have given to your security group, all right, he accepts and allows such requests, just like your security officer. All right, that's the same way your security group works. So in this case, there are two protocols and ports that we want to enable. So we want to enable the HTTP protocol because we're going to be deploying a web server on an HTTP instance using this VPC. We also want to enable the SSH protocol so that we can log in into our EC2 and be able to access it and do whatever it is that we want to do with that particular server. All right, so we're giving our security group those two instructions. So which means anything that is outside of those two instructions is going to deny them automatically. So for example, if somebody is trying to transfer a file, all right, into our server, it's going to drop those tracks because I don't have that instruction. Okay, so that's the way it works. Again, so let's give our security group a name. So let's say free class, all right, SG. So security, free class security group. Now let's specify the inbound group. Now for AWS, the way the security group works is this. Your security group is something that is referred to as a stateful firewall. All right, a stateful firewall. Okay, what does a stateful firewall mean? A stateful firewall basically means that whatever it is that you are specified as inbound is automatically allowed to come out by default. So which means I don't have to specify inbound and specify outbound again. All I really need to do is to specify what traffic should be allowed to come in. All right. So the same way you give your security officer an instruction that says anybody that is on white is allowed into this premises. So automatically, if somebody that is on white enters your premises, by default, if they want to leave your premises, they're allowed to leave automatically. They're not going to be questioned. That is the same way that your security group works. All right. So the only thing that matters is what do you want to allow into your system. So in another language, in networking, you can call it ingress and egress. All right. So ingress is what are those things that are allowed in. Egress is what are those things that are allowed out. All right. So, but in the case of security group, it is stateful in the sense that you are only just to specify your ingress or what you want to allow in. Automatically, every other thing is allowed out by default. Okay. So we edit our inbound rule from here. We're going to delete this and then we're going to add a rule. Now, two protocols. So the first one is SSH, which is protocol 22. We want to allow, all right, anybody from anywhere to access it. All right, it's just practice that we're doing. We can't tie to your IP address. If you are in an organization, for example, and then you have a public IP, maybe your ISP, your internet service provider, they're giving you a public IP address. You can actually tie this to your company's public IP address so that anybody that is not within the organization will not be able to have access to your server. That is also, so if I go to my IP, for example, now this is my own public IP address that is given to me by my own ISP. All right, so I could use this, but of course I don't want any kind of issues and all that. So I can just say, you know what, just allow anyway. Okay, and then I will add another one, and that will be HTTP because I want to host the website on this particular on a server shopping. So save changes. So I've specified those two rules, and if you look at it here, the two rules have been specified. The source says the 000 that I said earlier, I said it means anywhere. All right, so which means anybody from anywhere can access our resources. Okay, so that's what I mean. So if you go to outbound, you will see that your outbound by default permits everything. So what really matters in security group is what you specify at the inbound level. That is really what is critical, right? So that is done. So everything has been set up on our VPC end. So now let's go to EC2 and let us deploy a server, and let's connect that server to, all right, to that instance, and let's see how it works. All right, so I'll go to my instance here. I just want to deploy a single server. So I'll click on instance, launch instances. All right. Okay, so let's just say web server. Let's go with Ubuntu. All right. Yeah, so T2 micro by default, let's leave it. By the time we talk about EC2 next week, Monday, we're going to understand all these things, all right, in depth. So, but for now, let's watch what we're doing. Okay, so web server. So I'm choosing Ubuntu operating system. All right, the instance type that I'm using, which is the architecture. All right, I'm using T2 micro because it's under the free tier. So I'm not going to be charged for using this. All right, so I don't want to incur any cost. Now, security, all right, keep your name, which is a security key for you to be able to authenticate into your server. You need to specify that. We're going to talk about this on Monday as well. So here, I need to specify my VPC that I just created. So I'll click on edit. and then I'll go to this one. So this is the VPC we created. I'll choose that. And then this is the only subnet that we also have. So I'll choose that. And then I already have a firewall that we just did shortly, that we just did now. So I'll click on that and then select it. So that is the security group right here. It's the default one. So I'll choose that and then I'm done. So all I need to do now is to do what? Launch the instance. And then let's go back and let's see our instance. Right. Okay, so let's go back here and let's go to instance running. All right, I just want to view the instance that are running. Okay, still not running, so let's wait a bit. Let me just refresh. It should pop up here in a minute from now. All right, so it's popped up. So I'm filtering based on instance that I run. I don't want to see all those other instances. I just want to see the one that is running. So my instance is running. So if I click on this guy, if I go to security, you'll see that all those two things that were specified is actually there, right? Everything's there. Okay, so if I go to details, you will see here that I have a public IP address, and then I also have an IPv4 DNS, right, which we enabled earlier. Okay, so if I want to access this guy, remember we have opened up port 22 and port 18. So let's connect. So connecting here is port 22. All right, so let's click on connect. So this is how we can test if our VPC is actually working or not. So let's see if what we did is correct, if we can access our instance. Oh, wow. So it shows that truly our VPC connection is actually active. And then if I also want to be sure again, there's a way to be sure. I can run an update, right? So for Ubuntu, if I do apt, but first of all, let me elevate my privilege and log in as a root user, right? I want to log in as a super user. I can just do sudo-i, right? So from here, if I want to test if my network connection is working, because what we have just done is the first step. So we've been able to connect via SSH, and then it was able to connect. That is fine. So that shows, or at least on one side, that the network is working fine. But if I really want to know if I'm connected to the internet, I can do the ping that we did earlier. So I can do ping zoom.us. So right now, I can also see that the internet is actually working because it was able to resolve the zoom.us and I'm able to browse. So if I do apt, all right, I just want to update some things on my Linux. I can do apt update. All right. And then with this, it also shows me that my internet is actually working on this particular machine. So which means the VPC that we just configured is working properly as expected, and then there's no cause for alarm. So again, let's install the web server. So I'll say apt install. So these are just the Linux command, Apache 2. All right, so I want to install the web server. So let's see that in action. So this shows that my internet is actually working very okay. So everything is working as expected. My VPC is working, my internet gateway is functioning. All right, now the Apache has been installed. So if I want to verify if my web server is running, what do? There are a few things we can do. You can check from this particular environment as well. You can run a command that is called system CTL and Linux. All right, and then you do status. Okay, status Apache 2, the name of the service we just installed, and I press enter. And so it tells me that that status, that service is actually running and everything is fine. So how do I access this particular guy? Very simple. I can come back here. I can cancel this. And then I can, again, let's filter by, I only just want to see the instance that is running. All right, so let's click here. So I can copy this public DNS, or I can copy this public IP address, right? So if I copy the public IP and I go over here and I paste it, right? So you can see that I have my web server running, installed ready, and this is my IP address. Now, if you take this IP address and you check it on your own end as well, right, you will be able to access this page that I am on. I put that in the chat section. So if you go to this particular website and refresh it, you should also have this particular page, all right, displayed to you. Okay. You have this page displayed to you as well. So that shows us that our VPC was configured properly. Everything is working as expected. All right. And then VPC is functioning properly, it's functioning well. And that's why we are able to see this page that we are seeing right now. Okay, so that is that on VPC. There are other things that we can look at on VPC, but of course, those are advanced stuff like a NAT gateway and all those kind of things. You know, those are some of the resources that you use on AWS. All right. Okay, so that is that. So if you have any questions, you can go ahead and ask your questions. All right, so you can unmute yourself now, and then you can ask your question. All right, if you have any questions to ask. So let me just stop the recording.